Possible to imagine a world without pain relief? We depend on this drug to an unspeakable degree, yet few of us know what's available or how they even work. So today we are going to talk about Vicodin. It's a powerful prescription of drug and a pain reliever that is used to get rid of the moderate to severe pain. At the same time, there is the fear of dependence, addiction, as well as the suffering. There are many different side effects that accompany the use of Vicodin.
Vicodin was made in Germany by two German chemists. The first chemist's name is Karl Monick, creator of the Monick reaction and a professor of pharmaceutical chemistry at University of Berlin. And the second chemist's name is Helena Lovenheim. The drug was first synthesized back in 1920. However, Vicodin was introduced to the world in 1983 by no pharmaceutical company. The Food and Drug Administration approved Vicodin on March 23rd.
The body in a number of ways. The drug can cause excessive drowsiness and therefore more prone to sleeping. The drug also affects the body's reward system, tricking the brain to think that obtaining the drug will replicate the wanting feeling. Another result of Vicodin is a decreased breathing rate and heart rate. This provides a risk of lack of oxygen to be delivered to the brain and other organs. Vicodin increases the perception of pain after the usage of it. Therefore, the user will be more sensitive to pain than prior usage. Vicodin also causes irritability, anxiety, and lower stress management. Vicodin can be taken through 5 common methods. First method, oral route. Second method, inhalation route. Third method, topical route. Fourth method, rectal route. And fifth method, parenteral.
Though we know that Vicodin does provide pain-relieving effects, the mechanism for the drug is not certain. However, we do know the components of the drug. Vicodin is made of 2 main components, acetaminophen and hydrocodone. Both drugs provide pain-relieving effects. As you can see, acetaminophen is an organic molecule which can be synthesized in a typical chemistry laboratory. Acetaminophen is considered to be analgesic, meaning that it causes pain relief to the user.
The original method for reducing acetaminophen involves the idea regarding nitration of phenol mechanism using sodium nitrate, which results in giving a mixture of 2 isomers. However, we use the 4-nitrophenol because it can easily be separated through steam distillation. The nitro group is then followed by the reduction mechanism using sodium borohydride, in this case leading to an amine, 4-aminophenol. Finally, the amine group on the 4-aminophenol proceeds with the acetylation mechanism by using acetic anhydride, which finally creates the product acetaminophen. Acetaminophen inhibits cyclooxygenase enzymes COX-1, COX-2, and COX-3 located throughout the body. These enzymes are responsible for the body's inflammatory response. By inhibiting these enzymes, the user is able to increase their pain threshold. The mechanism for both components and their interaction with the body and central nervous system has still not been fully understood. Acetaminophen is metabolized by the liver through 3 major parallel pathways: glucuronidation, sulfation, and oxidation. The glucuronic and oxidative pathways both follow the first-order rate processes, where the concentration of acetaminophen increases as the concentration in the liver as well increases. The sulfate pathway pertains to the Michaelis-Menten kinetics, where the acetaminophen concentration remains constant once the liver concentration of the liver goes
is a more complicated organic compound with more steps needed to be synthesized. The combined effects of these drugs provide what makes Vicodin work the way that it does.
There have been several ways of synthesizing the hydrocodone molecule, either by using the thevein molecule or the codeine molecule. In this case, the codeine molecule turns out to be the most promising molecule to use for the synthesis of hydrocodone according to the experiment carried out during 1950s. What is very significant is the idea that along with this molecule there has to be an ideal solvent in order to furthermore proceed to the next reaction. In this reaction, the ideal solvent would be ethyl acetate. So starting off with the codeine molecule, the mechanism required to proceed to the next step is catalytic hydrogenation, where the alkene is treated with a metal catalyst, in this case palladium. The catalytic hydrogenation mechanism leads to the formation of the dihydrocodeine molecule. Remember the idea of having an ideal solvent? This is very crucial to have because the goal is to create a pure dihydrocodeine molecule that will lead to the synthesis of hydrocodone. The experiment carried out in 1950s included the solvent dilute acetic acid. The dilute acetic acid led to the product of the codeine molecule looking all gummy and not looking well enough to produce a pure dihydrocodeine molecule. Therefore, ethyl acetate is the ideal solvent used for this reaction. Continuing off from the dihydrocodone molecule, we move forward to synthesizing hydrocodone through the Oppenauer oxidation mechanism. The Oppenauer oxidation mechanism is used in a solution of potassium dibutoxide where the conversion of the secondary alcohol group to ketones takes place. Hydrocodone is metabolized by O-demethylation to hydromorphone through the liver enzymes. Then through N-demethylation, hydrocodone is further metabolized to norhydrocodone. In addition to these oxidative metabolic pathways, there is a 6-keto reductase pathway that converts the 6-keto group of hydrocodone and hydromorphone to epimeric alcohols. The 6-A-hydrocodone metabolite of hydrocodone is more commonly known as dihydrocodone, DHC, and is also marketed commercially as a semi-synthetic opioid analgesic.
Pain relieving effects are caused by the lower perception of pain located in the spinal cord and at the higher end of the central nervous system. The key component used in Vicodin, hydrocodone, attaches to the OP1, OP2, and OP3 opiate receptors in the central nervous system. However, the drug mostly affects the OP3 receptor. OP1, OP2, and OP3 opiate receptors all affect the analgesia, or the pain relieving response, but they have also different cognitive functions as well. Hydrocodone attaches to the mu receptor, located in the pain modulating regions of the central nervous system, the kappa receptor, located deep layers of the cerebral cortex, the delta receptor, located in the limbic regions of the central nervous system, and the sigma receptor, which is believed to use agonists, a substance that causes a physiological response, to mediate two effects on the brain. The two effects are dysphoric effect, and the other one is the psychotomimetic effect, which is the ability to put the mind into a similar mental state as a psychotic state.
After going through the complex chemistry and biochemical mechanism of Vicodin, it's a powerful demon that can sneak up someone and take over their life before they know it has even happened. Overcoming drug addiction is a long and often a painful process. There are so many things people can do to get help from others, and there's no better time than the present. So that's pretty much done, and here are a few sources that sort of help us through the presentation. And then thank you for watching.